Okay, my best guess, even though they have changed the format, is that you still have the same amount of time to work on problems. So I'm going to still show you the pace I would go at as I work on the problem. So I read the problem slow and careful again. So I make sure that I notice it says the function g. This is g prime though. So that the function g Okay, so the function g is defined and differentiable on the closed interval -7 to 5. The word differentiable is sometimes needed. And they say g of 0 equals 5. Might need that. The graph of g prime, the derivative of g, that's this, consists of a semicircle and 3 line segments. So 1, 2, 3. Find g of 3. Okay, many AP problems what you have to focus on is what are they giving you, what do they want. Well, they're giving me g prime and they want g. That's the fundamental theorem. I remember Danica's chart that if I have g and g prime and they're giving me g and they're giving me g prime but they want g, I'm going this direction. This direction means I need to use the fundamental theorem of calculus. Now, because notes are allowed on this year's test, you don't have to memorize, you just have to find it on the sheet quickly. So this is the formula I want to use. Other than this will be g prime, this would be g, this would be g. And I'm trying to find g of 3, so I want the rearranged version of this, but let's just use that for a second. So if I integrate from, let's see, I know the value of g at 0, trying to find the value of g at 3, so I integrate g prime, that must equal g of 3 subtract g of 0. Rearranging, this is 5, so I'm going to end up with g of 3 will equal let's see, bringing this over, that would be 5 plus the integral from 0 to 3 of g prime. Because g prime is shown, I can start at x equals 0, and I integrate to x equals 3. For this entire span, every value of g prime is positive. So if I find this area, it all counts positive. This area also counts positive. So I'm going to find the value of the integral by calculating area. I remember this formula. I don't have to remember, I just looked it up on the golden notes. Area of a semicircle. So that's going to be pi over 8. The diameter of this semicircle is 4. That gets squared. But I'm only taking a quarter of it, so it's half of this again. So I multiply this by 1/2. That's the area of this quarter circle. Plus, I need to find the area of this triangle. That's 1 times 3 divided by 2, so that's 3/2. And remember, numeric simplification is not required, so I don't want to go any further. I just want to stop there. The way points are awarded on this particular problem, if you have this statement for g of 3, you'll get 2 points. 1 point is for remembering that you needed to have 5 plus, that's right here, and then this expression would be the second point. So 2 points total for this finding of g of 3. I'm going to copy this. Now we'll find g of negative 2. So we can erase everything. We still use the fundamental theorem again. So now we have the integral from 0 to negative 2, but I don't really want to go backwards, so let's go from negative 2 to 0. G prime must equal, remember this is on the top, so that's g of 0, subtract g of negative 2. Rearranging, we would move this to this side and then move the integral to that side. So we would end up with g of negative 2 equals g of 0, which is 5, subtract the integral from negative 2 to 0 of g prime. From negative 2 to 0, all values of g prime are positive, so therefore all of this area will count as a positive number when we find this integral. So g of negative 2 will equal 5 subtract. We've already done this area before. Remember it was half of this. So that's pi over 8. The diameter is 4. That gets squared and I take half of it. And because numeric simplification is not required, you want to stop there and you'll earn a point for having that. So as long as you have this, you get that point.